So imaginary numbers and complex numbers. Imaginary, we always use an I, and you'll always see it with like this little curve on it. If you don't, and you write it like this, sometimes it can be mistaken as a 1. So you'll always see it have that little curve with an I. Um, so complex numbers, so this up here, a complex number has a real part and an imaginary part. That's why it's called complex. Um, a real number is something like 1 or 12.38 or negative 0.87, 3/4, or the square root of 2. We can find the square root of 2. It will give you a decimal. Imaginary numbers are like the square root of -2. So if you try to take the square root of a -2, so second the x squared button, and you type in -2. Notice it tells you non-real answers. So then 3i is the same thing. It's an imaginary number. And then the square root of -1/2. That is going to result in an imaginary number. So there's the biggest thing that you need to remember when you are talking about imaginary numbers are the rules. So there are 2 main rules. So rules for imaginary numbers. And these are just things that you have to remember. There's not really a trick. So if you take the square root of a -1, we write it as I. So its square root of a -1 becomes I. Anytime you have an I squared, an I times an I, it can be rewritten as a -1. Because remember, it was a negative, it would have been a negative under here times a negative. So anytime it's I squared, you always rewrite it as I. Sorry, -1. So go ahead and highlight that. It's huge. You have got to remember it. If you don't remember these rules, imaginary numbers are going to be harder. Yes, I know if you hate math and you hate real numbers, you're going to hate imaginary. I actually don't think it's too bad. For the most part, you just treat it as a variable, like you would just write it as 3i. The only difference is these rules right here. So instead of just writing 3x, you write 3i to say it has that imaginary number. Okay, and you guys know me and my clouds. Okay, so if I have the square root of a -9, that's the same thing as saying I have the square root of a -1 times the square root of 9. Because -9 times the square root of 9, since they're both under the square root, it's just the same thing. You can always, if you remember simplifying radicals or simplifying square roots, you can always just separate them out. We will be doing simplifying radicals tomorrow, but or in the next couple of days. I don't remember if it's exactly tomorrow, but so you can break this up as the square root of -1 times the square root of 9, because -1 times 9 gave you that -9. Now, based on these rules that we just wrote down, the square root of -1 is just an imaginary number. So you rewrite this as I times the square root of 9. Well, what is the square root of 9? It's 3. So it'd be I times 3. And remember, just like a variable, you always want to write the number first and then the letter. So you would write it as 3i. So that's it. That's all you have to do. Change the square root of a -1 to I, and then change the square root of 9 to a 3. Okay? If we take the square root of -3 400. We're going to rewrite it as this, and you can write it all under the same thing. It really doesn't matter. I'm going to show you both just because if it makes more sense that way. So you can write it under the square root, -1 times the square root of 100, and then you can break it out, -1 times the square root of 400. It's again, whatever helps you. So now, remember the rule, the square root of a -1 is just an imaginary number, times the square root of 400, let's see what that is. So the square root of 400 is 20. 20 times 20 gives you 400. And then your final answer, you write it with the 20 out front. So 20I is my answer. Okay. Now if we add and subtract, imaginary numbers, you're going to combine like terms and simplify. So if I have 2 plus 3i plus 7 minus 4i. So it's the same thing as when you use x. You're just going to combine numbers with numbers, imaginary with imaginary. So 2 plus 7. And notice, sorry, I forgot to say this. This is an addition sign. So remember, if this was a subtraction sign, we'd have to distribute it. But since it's just an addition sign, you're just going to combine 2 plus 7 and then 3i and -4i. So 3i, -4, or minus 4i. Remember, don't forget to take the sign with it, or you will end up with the wrong answer. So 2 plus 7 is 9. And then 3i minus 4i. 3 minus 4 is -1i. Just like with variables, you don't have to write the -1, so you could also write it as 9 minus I. 1i is the same thing as just, or minus 1i is the same thing as just minus I. So whichever, and this was adding because there's an addition sign between. Let's go ahead and do a subtracting one. So if we have 3 plus 6i minus 2 minus 4i, and this is subtracting because of that sign right there. Okay, so remember when we subtract this parentheses, it's almost like there's a -1 right there. So I need to distribute the negative. So -1 times 2 is -2. A negative times a negative is a positive, so it'd be positive 4i. So it'd be 3 plus 6i minus 2 plus 4i. Combine the numbers with the numbers. So 3 minus 2 is 1. 6 plus 4 is 10i. So that should be pretty simple, just like we've been doing for a while. Since there is no multiplication, there's no I times I or I squared. We will do that though when we multiply. So here we're going to do an example of finding the product or multiply. Imaginary numbers. So if I have 3 plus 4i and 2 minus 3i. So notice there is no addition or subtraction sign, so that just means multiply. So this is multiply. There are two ways you can do it. You can either use the box, or you can do like you've always done and just distribute. It doesn't matter to me which way you do it. If you do it in the box, you would set it up (3 plus 4i) and 2 minus 3i. So 3 times 2 is 6. 3 times 2 is 6. 3 times negative 3i. 3 times 3 is 9. Positive times a negative is a negative, so it'd be negative 9i. Negative 9i. 4i times 2. 4 times 2 is 8. And it's a positive 4, so it would be 8i. And then 4i times negative 3i. So 4 times negative 3. I forgot to write this one, sorry. 4 times negative 3 would be negative 12. I times I is I squared. So it'd be negative 12i squared. I just did them in the same steps so that you could see whether you use this or you use the box, it gives you the same thing. Okay, combine like terms. So we have 6, negative 9i plus 8i. If I owe you $9 and I give you 8, I still owe you $1 more. And then minus 12i squared. This right here is negative 1i. So it'd be 6 minus 1i minus 12i squared. Okay, now if you look back at those rules, the other rule you have is anytime you have I squared, it equals a negative 1. So this right here, and I'm going to highlight it just so that you see it. So I squared becomes, let me find my pink, I squared becomes a negative 1. So it'd actually be 6 minus 1i minus 12 times negative 1. So negative 12 times negative 1 would be a positive 12. So it'd be 6 minus 1i. Negative times a negative is a positive, so positive 12. Now there's actually one more step of combining once you do that. So 6 plus 12 is 18, so it'd be 18 minus 1i. This again becomes negative 1, so it'd be negative 12 times negative 1, which is positive 12. 6 minus 1i plus 12. 6 plus 12 is 18 minus 1i. Now, you will have noticed that I always write the term with I at the end. That is the proper way to do it. Even up here, I did the same thing. When you're using just x or y or whatever variable you're using, you always write it at the front. You always do 8x plus whatever because of standard form. This one, you always write the I at the end. You will see it on occasion with it not written in the beginning or at the end, but it's typically, you always write it as the number plus or minus whatever. Remember, this is a complex number because it has a real number part and an imaginary part. So I'm going to go ahead and I want to write this out. So this became negative 1 because I squared equals negative 1. That's that rule that we talked about. So I squared equals negative 1. Okay, so that is using imaginary numbers. Make sure that you use that little curdly I. Make sure you pay attention to if it's multiplying or if it's adding or subtracting.